Now that we have an intuitive understanding of a limit and have worked with them a little bit, we're going to formalize the definition of a limit. Let f be a function defined on an open interval containing a, except possibly at a. Then, the limit as x approaches a of f of x is equal to L if for every positive number epsilon, there's a positive number delta, such that if the absolute value of x minus a is between 0 and delta, then the absolute value of f of x minus L is less than epsilon. Okay, what? I'm going to illustrate this with a picture. What we have is y equals pi x squared, and I'm thinking of this as like y equals, or area equals pi r squared. And let's suppose we're targeting for our L, we're going to target the number 1. So we can think of the epsilon. Look, the limit is related to the output of a function, right? So we have this f of x minus L. These are y values. And we can think of the epsilon as an error in the output of a function. Like, for instance, say you're tasked with building solar panels, and you need the area of the solar panel to be like 1 square meter or something like that. And for the application that you're using, it doesn't need to be too precise. So you're okay with the error being like plus or minus 1/2 a square meter. So that becomes our epsilon. So if I want my area to be within the interval of 1/2 and 1.5, between 1/2 and 1.5, then what I'm saying is I want the output to be inside of this interval on the y-axis. Now the input that'll give me the value of 1, we can see is somewhere around, I don't know what that is, say somewhere around 0.56. But again, we have this leeway, right? I can be off by as much as 1/2 a square meter either way. So I can see from the picture here that if my input is between, say, 0.41 and 0.7, so if my input is somewhere in this interval here, then the output for the function is going to be between the 1/2 and 1.5 that I wanted. This becomes my delta, and we'll say that this 0.56 or whatever that is my A. So for a limit of 1, if I'm allowed an error of 1/2 either way, then I see that for the input radius, right, area is pi r squared, right? For my input radius, I can be between 0.41 and 0.7, and my target area will be within the specified region. So I said we can think of E or epsilon as error in the output. We can think of this delta as a difference in the input. Now let's go back to the definition. So what this says is, for every number epsilon, there's a number delta, such that if I'm close enough to A, right, delta tells me close enough, then my output, f of x, will be close enough to L. That's my epsilon. Now, I don't think that this really explains the definition, but we're going to keep going. Suppose I now say, I want to tighten this up, and I want my error to be no more than 2/10. So I now have this new epsilon. So now I want to contain the function between these red bands. What I can see is that dictates a different interval on the x-axis. So as long as I'm this close to 0.56, and it looks like that's close to about 1/5, as long as I'm within about 1/5 or 0.2 of 0.56, then all those inputs will give me outputs for the function that are contained in this red band here. I still don't think that explains it, but we're still going to keep going. Now suppose I tighten this up even more. Now I say my epsilon is only 1/10, right? So now what I'm saying is if I'm between these two blue marks here, then the absolute value of f of x minus L is less than epsilon. And the absolute value means that I could be either above or below my target L of 1. Now remember, I want to be contained between the two blue dashed lines. When I say contained, what I mean is I want the output of the function not to be higher than this blue line and lower than this blue line here. And I'm going to achieve that by tightening up my interval on the x-axis. And as long as I'm within that blue interval now, and that becomes now my delta, as long as I'm within this blue interval for my inputs, then my outputs won't be bigger than this blue line or less than this blue line, right? So if my x values are close enough to 5600ths, then my y values will be close enough to 1. Okay. Now, I think that does an okay job. I hope that does an okay job of explaining what these inequalities are about, right? So another way to put it is if I'm within a delta neighborhood of x, within a delta neighborhood of A on the x-axis, then my output will be within an epsilon neighborhood of L for the y-axis. Now, I think that I hope we have an understanding of these inequalities, but that doesn't really help us understand the definition of a limit. The definition of a limit says any epsilon you tell me, I need to be able to come up with a delta that makes everything work. And I think the best way to see what this means is by looking at a situation in which it fails. All right, so we're going to look at a situation in which a limit fails to exist. So I'll just mark an A here, I'll mark an L here, and here I have a function here that has a gap. So y there, x there, and say there's my limit L. And if I define an epsilon neighborhood that's, I don't know how big that is, but however big that is, if I define that epsilon neighborhood, then yeah, I can come up with a delta neighborhood. Let's say this is there. I can come up with an interval on the x-axis such that for all of these input values, my output value is between these specified dotted lines. But I don't know what happened there with my voice, but if I make epsilon really small, like I did that last time, then I now have a situation where I don't have any interval on the x-axis such that for all those inputs, my output is between the two blue lines. You see there's a gap here, there's a vertical gap. This is a picture of a limit failing to exist, and this is now an epsilon for which I cannot specify a delta that lands the function in between these two bands, right? So the definition of a limit says that for every epsilon greater than 0, there exists a delta greater than 0 such that if I'm within delta of A on the x-axis, but not equal to A, right? This says strict inequality, x does not equal A, right? That's the except possibly at A business. Anyway, if I'm within delta of A on the x-axis, then my output will be within epsilon of L on the y-axis.